Could you stop playing with your lighter? We're going to Stuttgart today, and their hot topic is epitaxy. Epitaxy? Does that hurt? Not at all. Susanna will explain what it's all about. Susanna, you're fabricating the lasers by means of epitaxy. How does this work? We fabricate the lasers by means of metal organic vapor phase epitaxy. At high temperatures, 600 to 700 degrees Celsius, we can stimulate gaseous semiconductor metals to deposit in layers on a substrate. It's like crystal growing in nature, just faster. This is the gallium arsenide wafer we'll insert into the reactor. It's the carrier substrate for the final lasers. This is the finished wafer. You can see interference rings caused by the slightly varying thickness of the layers. Okay, the semiconductor lasers are now finished. What needs to be done next? Now we'll have to check whether the process was successful, meaning whether it lasers or not. Yep, it's working. Excellent. Hi, Frederick. I finished the fabrication of the lasers. Now it's your turn. Thanks. Next, we'll modify the microlasers with a focused ion beam to determine the exit profile of the laser. I'll fix the sample on the carrier. Then I'll adjust the sample stage so that we can exactly determine the spot that needs structuring. That's a little tricky, as this spot is rather tiny compared to the sample size. So what does this fib do? The fib can both measure and structure, which is to say we can take highly resolved images with the integrated scanning electron microscope or use the focused ion beam as a kind of nano-scalpel with which to cut tiny trenches into the sample. Aren't they doing amazing stuff in Stuttgart? Yes, I know you're fond of the people in Stuttgart, but the things they do in Ilmenau are also fantastic. They make membranes out of aluminum nitride. It's crystalline and flexible at the same time because it's so thin. How do you make the aluminum nitride? We make aluminum nitride on silicone wafers. They're inserted into a plasma chamber where we manufacture the aluminum nitride. How do you check the result? We analyze a fraction of the wafer under the scanning electron microscope. If we see the pillar-like structure, our aluminum nitride turned out well. See, we just can't do without the scanning electron microscope. Which gets me back to the facet eyes and the microlens arrays. Let me see. Stop, don't open it. This comes straight from the clean room. To fabricate our microlens arrays, we first use photolithography to define a master. The photoresist cylinders that are created during this process are heated and melt. Due to the surface tension, the molten surface takes on a spherical shape, and this shape defines my lens. After defining the master structure, a mold is replicated from the master. Next, a liquid polymer is spin-coated onto a glass substrate. Using a mask aligner, the mold is aligned to the glass substrate and pressed into the liquid polymer so that the polymer fills the gap between the mold and the glass. By exposing the polymer to UV light, it solidifies through cross-linking and the mold can then be removed. And don't forget to clean the spin coater thoroughly afterwards.
Eigentlich noch nerviger als die Umzieherei vorm Reinraum.